Advanced Math, Lesson 1. We're now ready for Part F. This is about transversals and different kinds of angles we get when we have parallel lines. This is still review from last year. Up here at the top, okay, you see two parallel lines. We know they're parallel by those little arrows that are on them, showing they're parallel. And the line crossing them is called a transversal. When we have that, okay, here's some larger pictures of this. The angles inside, between the parallel lines, are interior angles, and the ones on the outside are exterior angles. And so there are some special things about alternate interior angles and so on that we'll talk about here, or review here. These are interior, and they're on alternate sides of the transversal. So are these two. They are alternate interior angles. Alternate interior angles are congruent to each other. So this angle B and that angle B, they're the same letter because they are the same size. They are congruent to each other. Both of these angles are the same size. Over here we have these angles A and these B are alternate exterior. They're exterior angles on alternating sides of the transversal. Alternate exterior angles, and they're congruent to each other. That is congruent to that, and that is congruent to that. Alright, now down here, all four sets of angles that you see down here are corresponding angles. And they're congruent too. Corresponding angles. And they are congruent. Corresponding angles are in the same relative position. Here they're both above a parallel line and to the left of the transversal, or above and to the right of the transversal, or they're both below a parallel and to the left or the right of the transversal. They're in the same relative position. They are corresponding angles. Okay, and then a review of a bunch of properties we know about those. If two parallel lines are cut by a transversal, okay, then each pair, this is stuff I just said, we've labeled up here. All these different pairs of angles are congruent. Okay, so you have it in words down below, you have it kind of in pictures up above here. And if you happen to know that you have these two parallel lines and corresponding angles are congruent, sorry, if you have two lines that are crossed by a transversal and the corresponding angles are congruent, then you know the lines have to be parallel. It goes both ways. Alright, so that's that. Now, sometimes we have multiple parallel lines and a couple of transversals, and in that case we still have all the things with the angles, but we also have proportional segments, okay, because it's slicing these transversals into these segments, and you have this proportion, and that is always the case. And we're going to go ahead and use that one to solve example 4. We did these last year as well. But basically, 3 over 4 equals x over 6. And then you solve for x. So I'll be multiplying both sides by 6. And you can cross cancel or just multiply across and then reduce. 9 halves is x. 4 1/2. You can leave it 9 halves. And that is how you do problems like that. Alright, on to part G. Okay, so we have area and sectors of circles. Okay, so just area and sectors of circles. So area of a rectangle, you have a formula paper hopefully. But basically, here's your formula, length times width. Area is basically the number of square units that will cover a figure completely. Area of a triangle, again, is on your formula paper, but here it is just for your convenience. 1/2 times the base times the height. Okay, now the perpendicular distance from either the base or an extension of the base to the opposite vertex, that will be the height or the altitude. We're going to put both of them here. Altitude or height. Okay, and so down below here, it doesn't matter if it's a right angle, an acute angle, or an obtuse. It's always that formula. It's the actual base and the height of the triangle. So here the height is one side of that triangle. Here the height is inside. And then for the obtuse, it is on the outside there. It's always the perpendicular distance from one vertex to the opposite side or an extension of that opposite side. 1/2 times the base times the height. And as it says there, any of the three sides can be designated as the base. You could turn these around and a different side would be on the bottom. That's fine. Okay, now on to circles. Okay, so first a review of some vocabulary and then some properties. So we have right here, this is a radius, which we normally label R for radius. Okay, if we were to extend that, which I'll just do another one over here. Okay, there would be a diameter. See, here's a radius and there's a radius, so diameter is 2 times the radius. And then we need to talk about area and sectors, and that's why all these shaded things. The area of a circle is pi r squared. The circumference is 2 pi r. Up here we're going to talk about arc length. Okay, so instead of the whole circle, it's just how long is this piece of the circle. And to find that is a fraction of the circumference. And to find out what fraction it is, you take whatever this angle is here. So just going to call that x degrees. So x over 360 times 2 pi r gives us the arc length. Whatever that central angle is, divided by 360, this tells us what fraction of the circle that is, and then you take it times the formula for circumference, 2 pi r. Alright, down here, this is supposed to help demonstrate why that works. We know by looking at that, this is 1/4 of the circle. But if we use that formula, that's 90 over 360, which reduces to 1/4. So 1/4 is what we would take times 2 pi r if we wanted arc length, or pi r squared if we wanted to get the area of that shaded part. Because the area of a whole circle is pi r squared, this is only 1/4 of it. It's the central angle over 360, and then you take it times whichever formula it is that you're working with. So if we were doing area of that sector, it'd be 1/4 pi r squared. We just would need to know what the radius is. Here, central angle over 360 reduces to 1/2, and you can see that's half of the circle. This one's 1/3. 120 over 360, that's 1/3 of the circle. So for that one, we would take 1/3 times pi r squared. Okay, so for area of a sector, you do the fraction times the area formula. For arc length, it's that same fraction times the formula for the circumference. Now, part H, these are new. Okay, concept review problems. I very much enjoy these. They're usually going to be numbers 29 and 30 in your problem sets, and most of the time your answer is either A, B, C, or D, but you need to be able to support your answer. And you're always for those kind, you're comparing two things. You're comparing A and B. And if A is bigger, then you put A. If B is bigger, you put B. If they're equal, your answer will be a C. And if there is not enough information, then it's D. So we're going to take a look at 4 different examples here. And you'll see the types of problems to expect. They will vary greatly, but these are examples of some of them. So, let x and y be real numbers. If x is greater than 0 and y is less than 0, compare x plus y and x minus y. We want to see which one's bigger, or can't we tell? Alright, so x greater than 0 means x is positive. Y less than 0 means y is negative. So I'm just going to write positive, negative. So I'm starting out for A and B with the same number, and here I'm adding a negative number to it, and here I'm subtracting a negative number from it. We know minus a negative is the same as adding a positive. So here in B, you're always going to be adding more to whatever the initial number is, and here you're subtracting. Right? So then that means B is going to be larger, because you're actually adding to it. So the answer is B. Subtracting a negative is the same as adding a positive. That would be, I think, a good enough explanation for that. Okay? Now in example 6, x and y are real numbers. X is between 1 and 6, y is between 1 and 6, and we're supposed to compare x minus y and y minus x. Okay, well, let's think about this. If, let's say x is 2 and y is 5. Whoops. Okay, if that's the case, this is negative 3 and this is positive 3, then b is bigger. But x can be 5, and y can still be 5, and then it's 0, and then they'd be equal to each other. Or maybe x is 5 and y is 2. Okay, all of those fit the characteristics it says here. We're getting a different result each time. Here, B is bigger. Here, they're both the same. Here, A is bigger. This is D. It just depends. There's not enough information to tell which one should be bigger. It just depends on what happens, which exact value for each of them you have. So that one's D. You only answer A if A is always bigger than B, and you only answer B if B is always bigger than A. Okay, example 7. Given these intersecting lines and the angle shown, compare K plus L plus M with 180 minus N. Okay. 180 minus N. K plus L plus M. Okay. There are different ways of looking at this one. The first way I'm seeing right now is that K plus L plus M is the same as 360 minus N, because the whole way around here would be 360, but we're taking away N. So this is the same as 360 minus N. That's definitely larger than 180 minus N. So it's A. And again, sometimes there's more than one way of looking at things, but that's the first way I saw for that one. So, and this, I think, is just enough explanation, because you have that picture. You don't need to write a lot to explain these, but you should have a reason for your answer. And don't put D just because you glanced at it and don't know what to do. That doesn't mean there's not enough information. Okay, so example 8. Okay, given ZW and XY parallel, okay, compare the area of WXY, so this triangle, and the area of ZXY. Okay, so then that's this triangle. Just to compare those areas. Okay. You cannot go by appearance. We need to figure out if there is some way of actually figuring this out. So, what I'm seeing here is parallel lines. We know that they are the same distance across everywhere. The distance from here to here is the same as the distance from here to here, the perpendicular distance. And we know the height of a triangle is the perpendicular distance from the base or its extension. Okay? So this height is the same as that height. This is the base of both of those triangles. All right? So that means 1/2 times the base times the height of this triangle is the same as 1/2 times the base times the height of that triangle, because it's the same base and the same height. They're the same. Same base and height. So same area. They are equal, so that's a C. And that's all we have now for lesson 1. Enjoy.